By now we have a lot of the tools that we can start to solve some problems and look at some things, which are kind of fun. One of the things we can learn how to do is something called solving right triangles. Basically means to determine all the lengths and all the angles given some beginning criteria. So I have a triangle where I have two things I'm given. I'm given an angle of 34.5 degrees and one of the sides, which is 10.5 units or whatever it might be. So from there, I need to find all the other information that's available. So let's begin with the internal angles. I have one angle that's 90 degrees, another angle is 34.5 degrees. I need to find one last angle. Well, if I remember some of my earlier trigonometry and geometry, I know that the interior angles of a triangle all add up to 180 degrees. So 180 has to equal 90 plus 34.5 plus some x. And that's this value up there that I don't know yet. So if I were to find that out, that would look like it would have to be a 55.5. And just to check, 34.5 plus 55.5 equals 90 degrees. 90 and 90 equal 180. So we're off to a good start. Now from here, we need to find two more pieces of information, the side of A and the side of C. So let's begin in using some of our trigonometric identities that we have. So let's say, for example, that we were to look at the tangent of 34.5 degrees. Tangent equaled opposite over hypotenuse. So I have some A, or opposite over adjacent. So A over B, and B was defined as 10.5. I could solve that for A. That means then I'll have a 10.5. I'll divide both sides, or multiply both sides by 10.5, which will give me 10.5 times the tangent of 34.5 equals A. From there, I'll need a little black box to help me figure that out. So 10.5 times the tangent of 34.5 equals 7.21 approximately, or 7.22. So I'll say approximately 7.22. All right, and we just have one last place left to find C. And so let's go ahead and figure out from this angle, what measurements can I use to help me determine the B and the C? I think cosine is a good choice, because the cosine of some angle, or in this particular case, 34.5, cosine equals adjacent over hypotenuse, which is adjacent is a 10.5 over the hypotenuse. Yep, adjacent over hypotenuse. Solve that for C, or that side, that's going to equal C equals 10.5 divided by the cosine of 34.5. And equals approximately 12.474. So we just solved a right triangle, which meant find all the interior angles and find all the lengths of the sides. And we can do that by using some of our trigonometric identities that we're learning about and continue to practice. Now, trigonometry is first developed to help us to find some things that were inconvenient to find. So for example, the height of objects. So let's imagine I have a tower over here. I don't know the height of that object, but I set up some system 125 feet away, and I'm able to measure the angle from where my viewing spot up to the top. I'm able to measure that angle at a 57.2. So based on that information, am I able to discover the height of that particular tower or object, whatever you're able to use in your imagination. So how do we do that is we have to build a right triangle. And you can imagine I have a right triangle here. This tower comes on out. This forms a right triangle with a horizon. So I have a right triangle. I was able to mark off the distance from the tower to my viewing spot, which was 125 feet. And the other side is what I'm not sure of. So what can we do with that? Now, I always recommend on everything, especially in trigonometry, try to draw a picture first of the information that's present. And that's my best picture. The tower looks a little skinny in the middle, but that's all right. It's going to stand up to the strong winds. So I was able to draw a picture, start to fill in some of the information I need. Sometimes I might fill in information I don't need. I'm just filling in everything I can. So what I'm looking for is the height of A. So is there a trigonometric function that allows me to use this angle and the opposite over the adjacent sides? Yeah, that was a tangent. The tangent of 57.2 equals A, the opposite over the adjacent, which was 125. From there, we can solve from A. So let's multiply both sides by 125. And that would equal A. Use the black box to find the approximation of those numbers. So 125 times the tangent key of 57.2 equals 193.96. Let's round up to approximately 194 feet. So the height of this tower, based on the trigonometry that I was able to build into the system, shows me that the height is 194 feet. All right, now let's imagine we're out on the beach and I'm flying a kite. I've let out 65 feet of rope. The kite is 30 feet above the ground. The question I want to ask then is, well, what's the angle that my kite is flying at? Now remember, when we're trying to find the angle within a triangle, that has something to do with the inverse sign, because that's what inverse is asking us. Who's the angle, or what's the angle that produces such? So let's see what we have so far. Right now, if I call this theta, I know that my sine of theta, what was the sine? That was opposite over a hypotenuse. So it'd be 30 over 65. However, I want to find the angle in this particular case. So in order to do that, I need to take the inverse of sine of those 2 points, of 30 divided by 65. From there, we use the black box. The black box will tell us, so we have to look for the inverse sine key, which on mine is a second function of the sine. So second sine shows sine inverse of opposite over adjacent, or opposite over hypotenuse. 30 divided by 65 equals 27.48 degrees. So this is at 27.48 degrees is the angle where my kite is flying at on this particular day. So again, another opportunity to use some trigonometry to help solve some of the harder problems that we need to see and we are able to replicate in the world around us. Here's another fun problem, which kind of reminds me of the first time that I went up in a hot air balloon and we had a crash. We crash landed that hot air balloon. It was a fun experience and I got pictures of it. So anyway, let's use that idea of a hot air balloon lifting up to kind of get an idea of what we can do with some of our trigonometry. So let's say that I'm in a hot air balloon, and then after a few seconds, my friend who's watching me was able to observe that I was at a 31.7 degrees at a particular moment in time. Don't know what the height is, but a minute later, he observes again and was able to measure 76.2 degrees of a viewing angle. So the question is within this minute, how far did the balloon rise additionally? So this is a problem that we might want to use two different right triangles to help solve our problem. We're basically trying to figure out is how far did the balloon travel after he first spotted me above the ground, and then how far did it travel vertically the second time he was able to measure my distance or measure me from the ground. So what we can do is identify two right triangles. The first one is this smaller triangle here at the first viewing angle. I have a height which I'm not aware of. He was able to mark off 100 feet from the launch of the balloon, and he was able to measure 31.7 degrees. So that tells us that we have a tangent function there. So the tangent of 31.7 equals opposite over hypotenuse, which is, or opposite over adjacent, which is a over 100. Solve that for a, and then use a black box. So I'm going to find 100 times the tangent of 31.7 equals 61.7, 61.8 feet. So at his first spot, I was 61.8 feet above the ground. Now, a second time, he was able to see that it was a 76.2 degrees. And so I have another right triangle, but this time it's measuring all the way up to the top. So this one then would be the tangent of 76.2 equals my other height over the adjacent. So in that particular case, let's find that one out. Solve for b. That's 100 times the tangent of 76.2 equals 407 feet. So the question is how much did I travel vertically between the two observations? Well, I'm going to take the height, which was my second observation, which is 407 feet, and subtract it from this first observation, which was roughly 61.8. Let's round off to 62 for fun. And so the height I've climbed in that minute then would be the subtraction of those, which is what, 345? 345 feet. These are kind of fun.